Okay, so the last video showed us how to, maybe I like Times New Roman. The last video showed us how to create the data table with all of these values, including the fluctuation values. And hang on, newtons must be showing, and also how to create this chart. The next thing we want to do is we want to represent on our graph how much fluctuation there was in the static friction, in 3 static friction values. So this represents an average, this first data point. And really, it wasn't just a single value we recorded. We recorded this fluctuation, this range of values. Here's what half of the range is. Where is it? This is half of the range. You'll see why we used half the range in just a moment. This will become clear. Right? And what I want to do is represent that range up and down from the average, the range of the 3 values. So what you do is you click on your graph, you hit this plus, you choose the option that says error bars, and something pops up on your graph. Don't worry about what's there. First thing we want to do is get rid, so click on the horizontal, the X error bars, and delete those, because all we really have fluctuation in right now is the maximum static friction values. So the only fluctuation we have are the up-down fluctuations in the Y quantity in Fs max. So you click on the error bar, then you right-click and you hit Format Error Bars. Or you can click the plus. You can, at the error bars, click this little arrow and then do More Options. That'll do the same thing. Format error bars, more options. Okay, you want to have error bars going up and down. We want a cap. Caps are, they're good to have. And where you have error amount, hit custom. The amount of fluctuation in this average, right? This is the average of the 3. The amount of fluctuation at this mass in this average value was this. The amount of fluctuation in this value was this one. The amount of fluctuation here in this value, based upon the 3 measurements, the amount of fluctuation was this. So we want this column, to be paired with these Y values. So here's how you do that. You click on your error bars. You have error bar options, not this one, but the far right. Go to the bottom, do custom, specify value. Highlight the equals 1, delete or backspace, and then select this column, and then highlight this, backspace, select the column, hit OK. And now what we have is this. From this data point, we could have gone up or down, because the error bars go both ways, up and down. We could have gone up or down by this amount, 0.285. And on the next data point, there wasn't just this single value. There was fluctuation. And the fluctuation from the average could have taken us up or down by this amount, 0.353. Okay. Notice that the last data point had a really small amount of fluctuation in the 3 trials. I was really, really precise when I took those measurements, and I was really consistent in a way that reduced the fluctuation. So the fluctuation was much smaller, and hey, check it out. On that last data point, the error bars are almost invisible, almost too small to see. So what we can do to make them a little more visible, right-click on one of the data points, hit Format Data Series at the bottom, and then, finally, last thing, oh, here it is, Format Data Series. Click on the far left where it has line and marker. Not this one, but line and marker. Click Marker. And then where you see, let's see, Marker Options, hit Built In. And then for size, take it down to maybe 3. And now the data points are smaller, but the error bars are more visible. Okay, the next thing we have to do is create the same chart, the same graph, for the kinetic friction data for this, this, and this. And guess what? There's a really easy way to do that. Click your graph, so you're dragging it, clicking and dragging, holding down on the mouse. While holding down, you hit Control on your keyboard, and hey, let go of the mouse, keeping Control pressed over here. And you just made a copy. Click on one of the data points, and you see that these boxes pop up. The purple box shows you what's on the x-axis. The blue box is what's on the y. Let's see. Get your mouse so that it's over the blue box with the 4-arrow icon. And instead of average max static friction, move it over to average kinetic friction. And just like that, your graph updates. I'm going to click once, click twice, and then highlight to change this to FK. Right? I still want my, let's see, where's my, I click a data point. I still want normal force on the X, so that doesn't change. And then I'm going to change this to coefficient of kinetic friction. You double click on a word to highlight just the word. You triple click to highlight the whole box. Okay then, very good. And then I need to change my error bars. So I click on the error bars, right click, format error bars, and at the very bottom I change the custom, I specify value. Let me move this over. I'm going to highlight everything, backspace, and for the error bars it could have been up by the fluctuation amount or down by the fluctuation amount. Uh-oh. What did I do? Something's wrong. So get rid of this, get rid of this. Positive error bars, I click and I go to here. Negative error bars, I click and I go to here. Hit OK. And boom, there you go. Your second graph is done in just seconds. And then what you do is you open up Word. Let's see. Word. New. I'm going to move this over to the left and move this to the right. You put your MLA heading, including the header, right, with your name and page number. You say, the following raw data was collected. Oh, for the title, maybe friction experiment. The following raw data was collected. You highlight these first columns. You hit Control C and Control V. Right? Perfect. If you want to paste it, you can as a picture, and then you can easily kind of adjust the size. And give it a title, say Table 1, Raw Data. And if you want, you can center these things. Control E is the shortcut for center. Then, the following data was processed from the raw data. Center, Control E, Table 2, processed data. And then I'm going to highlight all of this. Control C, Control V, and if you want, you can make it a picture. You know what? I kind of like it better not as a picture. So if you want to center this, you kind of hover over the graph, the table, until you see this thing in the corner. See that icon in the corner? You click it, and then you hit Control and E at the same time. And I'm going to take this away, and I think I like it better not as a picture. So highlight, Control C, Control V, and then I click here, hover over, click on that icon, Control E on your keyboard to center. Then you have to show how your value. So remember the equation builder, you get to it by hitting Alt and equals at the same time. Or on a Mac, you can hit the insert, and then I think it's insert, and then you click object, and then a pop-up shows up. And from the pop-up, you choose equation, Microsoft equation, I think it is. Or you can go to insert on a PC. You do insert, and then at the far end, wait a second. insert, and then over here at the far end there's equation. So you hit the pi rather than the drop down. Insert equation or alt and equals at the same time. Okay, before we type the equation, here's what we say. The normal force values were calculated as shown below. Below is a sample calculation for the normal force at a mass of the first mass, 214.5 grams. So what's the equation for normal force? F underscore, so shift dash, N, then you hit space, equals. Normal force is mg. So equals, and then you plug in the mass, 214.5, make sure you include units, grams, and then click design, or no, just hit star. So before we did anything else, we converted this from grams to kilograms. So we wanted kilograms in the numerator, right? And then slash for divide by, and then you get space. And then you go to the denominator, and you 1 kilogram is equal to 10 to the 3 grams. De-italicize units. We don't ever italicize units. And then we have to multiply by 9.8, which has units of meters per second squared, like that. And then, of course, the value, which Excel found for us, of the normal force was 2.1021. Then, say how you found the average max static friction. Was calculated as shown below. Or you can say, a sample calculation is shown below for finding the average max static friction at a mass of 214.5 grams. So again, I'm saying here's how I got this value, which corresponds with that mass. Okay, colon, and then you plug in the equation, and I'm going to pause and then put it in. So here's how I wrote the equation. I used the fraction to get the fraction there. And then I'm going to hit slash equals to build the fraction. Then I go into the numerator and I say trial 1, the value of, so here's trial 1, 1.550, then 0.981, then 1.360. Make sure you include units, plus 0.981 newtons plus 1.360 newtons divided by 3, and the value Excel calculated as the average was 1.297, this number right here. And that, of course, has units of newtons as well. De-italicize. Then show how the fluctuation value was calculated, and say the same calculation was used for the average kinetic friction values. And then we put how we found the fluctuation. Max static friction was calculated below. Calculated as shown below in the sample for in the sample calculation at the mass, or at a mass of, what's our first mass? 214.5 grams. And I'm going to pause and put in that calculation. So I did fluctuation equals range over 2 equals max minus min over 2, and then slash equals to make the fraction the max of the 3 values. I look, I see, okay, where are they? The max was the first one, 1.550. The min was 0.981. So I finished the equation. And for that first row, Excel calculated the value to be 0.285. Then I say the same calculation was performed for the fluctuation in kinetic friction. Okay, then I introduce my graphs, and I'm just going to show you how this should look. You go into Excel, you Control C on your graph, click it, or on the white space, Control C, then